Hello, I'd like to go over the scientific notation practice worksheet. So scientific notation is a way of writing very large numbers or very small numbers in a short form, like a shorthand. These two here. For instance, this number down here, number 2, is 76 billion. Well, there's a shorter way of writing that, and it comes up a lot in science where you have these really, really big numbers or really, really small numbers, and you need to write them in a different way so you're not writing 30 zeros. Here's an example of a small number. This has got 0.00000002, so we can write that differently. All right, so here's how we do this. This shows you two good examples actually, but I'm going to go through a couple of these with you. So let's look at this first one, number 1. 3,500,000. All right, well, we want to start off with our first numbers here, and we want single digits. Or you just want to think of the ones place, right? We want to put we don't want 35, we want 3.5, a single digit number here. Times 10 to the something, but I have to know what to raise it to. It's very easy to figure that out. We see where we started with our decimal point, and we count how many times we have to move that decimal point over. So I started here, I moved over 1, 2, 3, 4, 5, 6. My new decimal point was right there, right? So that means this is 10 to the 6th power. Let's do another one. Let's look at number 6. 12 million. So I'm going to take my single digit number, 1.2. And if there was another number there, if it was 1, 2, 3, 4, I would put 1.234. So it's just this first one that you want to keep as a single digit. Times 10 to the what? Well, I'm going to count how many times I moved my decimal. 1, 2, 3, 4, 5, 6, 7. I moved it 7 times, so 10 to the 7th. So do that for all of the large numbers. Now let's look at one of the small numbers, number 3. I've got 0.00068. Well, that 68, I'm still going to turn that into a single digit number. So I'm still going to go 6.8 times 10 to the what number here? Well, we're going to do the same thing, only the opposite direction. I'm going to see how many times over I moved my decimal. 1, 2, 3, 4, 5. I moved it over 5 times. So this is a negative 5, okay? Let's look at the next page right here. Let's do a couple there. So now we're going to go back the opposite way. 4.2 times 10 to the 3rd. All right, so 4.2. I know I'm going to move my decimal 3 places. So I'd go 1, 2, 3. Add in my zeros. That is 4,200. Let's do number 10. So 6.0. Well, I'm going to move my decimal 6 times. 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, 0. That means that is 6 million. All right. 11 here has a negative number, so that's going to be a smaller number. But we're still going to do the same thing. 7.2. In this case, instead of moving it to the right, I'm going to move it to the left. And I move it 4 times. 1, 2, 3, 4. Fill in my zeros. That means my number is 0.00072. All right, so it's just the same method. And at the bottom, it gives some real world examples. So we'll just do one of these. All you're doing is changing these scientific notations into their full number. So 17, express the speed of light, which is approximately 3 times 10 to the 8th meters per second. So 3.0. I'm going to move it over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 0, 0. And that's going to give me a number 300 million meters per second. And that's the answer. Okay, hope this helps. Do the rest of these. Thank you very much.